So it's super important that this is airtight, because when I vacuum bag, and in particular I'm going to infuse the laminate on here, I do not want to have a air leak to this cavity here. If I have an air leak into this cavity, this will implode. Let's chop some resin pretty fast. Just imploded.
Shayne, do you want to tell us what you're up to?
I'm making a thing
You've made lots of things.
to go on the whatchamajigger to fix the duva. And that'll be my alarm.
Shayne has to send an email,
Yeah.
and that alarm has been going off every 10 minutes for the last hour.
Hour and 10 minutes.
Okay, so I guess the plan is that we have on Paikea, these are quite flexible walls, aren't they?
They're not flexible walls. They're the hull shell panel, and the hull shell panel is designed to work with certain spans. Okay, now a span is considered the distance between bulkheads, reinforcements like the now glued in floor, major geometry changes like angles in the deck up here at the shear line, or here at the hull to deck join. This is a shallow geometry change, so it's debatable whether it would be considered as a stiffening portion of the panel. But anyway, this is what we call the panel of the boat in engineering terms. But it's the side of the boat, and it experiences loads from waves, water going past, the boat being depressed in the water and the water pressure on the side of the boat, docking, fenders pushing against the side of the deck. So this whole side experiences all these different types of loads. What we need to do is support this panel, because it's primarily designed just to keep the water out and the boat floating. That's its primary job. We tend to not. This is an interesting engineering philosophy discussion between different engineering firms as to whether you reduce the number of frames to support the panels, or you increase the stiffness and strength of the panels to reduce the number of internal supporting structure. And there's multiple ways to do it. This boat is set up where it's a relatively light panel with a lot of internal structure to support the light panel. Right. So that means that things like the bulkheads here and here in the room are the primary supporting bulkheads taking all the load. There was once upon a time an ensuite type bathroom thing here, and it had this partial bulkhead here, which didn't go through under the floor, and hence why the previous owner, and us as included, fell for the mistake of thinking that when you're rushing around in the boatyard putting chocks and stands under there, you look, oh yep, there's a bulkhead there, and you forget actually that bulkhead doesn't go under the floor and go right to the floor, and we've cramped the bottom of the hull. That has all been rectified now, and there is actually a nice big strong frame in there, so we can put it in the yard, and we have another option for jacking the boat. I diverge. So we've got this partially structural piece of poop that's been glued in, but it is amazing actually how much this does support this big panel. Generally throughout the boat, you try and keep your station spacings relatively even, so that your panel span calculations are easier to deal with. And throughout this boat, the loose station spacings is 1.1 meters
Yeah, I think we spoke about that when we were talking about
Sockets.
the sockets and lining them up with the bulkheads would be an ideal situation. But
Yeah, it was just a little bit unfortunate. Instead of being at 1 meter spacings on the thing, it was 1.1, so you get the accumulative error as it moves through the boat. The bulkheads just keep moving away from the distortion sockets. Anyway, so this week is now replacing what's left of this ensuite frame with a box beam stiffener here to support this panel. So this needs to tie into this frame that's below the floor here, and it needs to then blend into the deck. I'm happy with the deck and its spans because there's some nice geometry changes to keep the stiffness happening. Globally, it's possibly a little bit soft when someone walks on it. You can see a little bit of deflection in it, but it's not anything to worry about, and we know it's more than strong enough because we've been sailing like this for a bloody long time. It's one of the first big mods we made was cut this silly room out, or ensuite out of this room.
yeah, so because if you can see here, we didn't bog this part of the wall because originally the plan was we would run a longitudinal through here, but then on reflection, it's actually, well, number one, it's a lot of work. And then aesthetically wise, we'd probably need to run it the entire length of the boat.
Not aesthetically wise, it was not. It's nicer. It gives this room a more open space. So that was the reason I'm thinking of putting the longitudinal on there.
Yes, but then you'd have to run it the whole length of the boat because then it would look a bit funny.
Well,
well.
Not look funny, but it needs continuity. You can't just take a longitudinal and stop it at a bulkhead. So let's take example, that bulkhead to this wooden bulkhead here of having the longitudinal. When this panel is pressured from the outside, this panel wants to deflect inwards, right? Meaning that this longitudinal wants to bend like this. When it does that, say that my hand here is the longitudinal, when it bends, it wants to bend like that, right? And what it does when it's connected to this frame is it wants to break the frame out of the boat. Okay, this is just grossly over exaggerated, obviously, but that's what it wants to do. So what you do with longitudinals is you don't stop them on a bulkhead like this, you continue them through. So you continue it through so that there's longitudinal on the other side supporting it and it doesn't affect the frame. You can stop it sort of at the longitudinal, but what you do is you put a long tapering piece of wedge on the other side here so that we distribute the load from the longitudinal through the frame and into the other panel on the other side, and it gets tapered away to nothing so that it softens and doesn't leave a hard point in the corresponding panel, but it blends out. And this is where we come to where Anna was talking about aesthetically. I didn't want to do that on the other side of that door frame because you come down the stairway and then you'd see this funny tapered wedge thing. So it would have looked funny on the other side. And what that also does is it adds weight because I've got to put this wedge on the other side of the longitudinal. The longitudinal is already quite long and distributing loads into the bulkheads versus I put this partial ring frame arrangement in here which does the same job and will end up smaller and lighter than putting the longitudinal in. So,
well, yeah, but aesthetically we were going to run the longitudinal at one point the entire length of the boat so that it looked
yes, correct,
the same. But then it was just a lot of work to do that. That's and it didn't make sense when we started having a better look at it.
Yeah.
And then even then we weren't entirely sure that it would do the job as well as this partial ring frame.
Yeah. Yeah, we're taking a small aesthetic hit in here in that we end up with a vertical protrusion out of the wall panel versus the horizontal one, which gives us a bigger feeling room. But structurally and weight-wise, this is definitely the better option to take in this particular case.
And then the other thing I was going to ask you is, what are you building it out of?
Yeah, okay. So here I've cut a bit of foam, and this actually will show you, give you an idea of what it's going to look like.
There's your alarm again. Don't forget that.
My 10-minute snooze to send my email to deal with other projects.
That's what happens when you have to work for a living.
Yeah.
Okay, so that's what it's going to look like. So that's 10 mil foam. You're obviously going to do it a bit bigger.
Okay, yeah. So this piece of foam that I've got another one cut upstairs, and it's going to create a box that's going to be glued to the hull panel, and it's actually going to have a lot of eglass unidirectional on the top flange of the box. It goes through there, and a lot of double bias to carry the shear loads through into the wall, and also there'll be some eglass unis going onto the hull panel as well to just connect that and make it a whole box section.
It's going to be a pretty grunty box section though, with how much uni?
Yeah. It's going to be 5 mil thick.
Ooh. Yeah.
Like substantial.
Yeah. Is that sort of close to what you were doing with the ring frames?
With the bulkheads.
With the bulkheads? And
yeah, so...
the edge capping?
Yeah. So I have I'm using the existing bulkhead EIs as my baseline, and basically getting this to match the EI, so we have an EI match between the different bulkheads.
EI?
Yeah. Whole nother discussion.
Engineering intelligence. Is that what it is?
Engineering intelligence. Yeah. For those who know, they know. And for those that don't, it's not a 5-minute explanation.
Well, just what does it stand for, Shayne?
E multiplied by I. That's your young modulus multiplied by your second moment of inertia.
Okay, right. Maths.
Yeah.
That's your homework if you're listening and you want to know.
Yeah.
We won't get him started on that one.
Yeah.
Okay, so then that's pretty much the job. There's our pup falling boy.
You need a new t-shirt.
What'd you do to it?
No. What did you do to it?
Yeah. You like that one?
Yes.
So this foam here actually doesn't really do anything other than create a former for the glass. It has no real structural... I'm lying a little bit. It helps the sides where it's going to be just a very lightweight 600 gram double bias on the sides, stop from local buckling. So technically it does have a structural component because it stops the fiberglass from going wobbly when it's all loaded. But the actual foam itself does not carry any load. All it is here for is creating a former for this particular thing. Yeah, I think there is a lot of people out there that have a very large misconception of what foam is and what its role is in composite panels, and very, very much misunderstood. We've seen a lot of rubbish put out there by people that this method of building is not great and that other methods are great, because they just purely misunderstand what this material is for and how it works in conjunction with glass and carbons and things like that, and what this foam core's role is and how to best
Utilize
its properties and what it's really for. So
I think that goes back to what we were saying before about fit for purpose.
Yeah.
That you need to have a look at every project that you're doing on its own and in conjunction with how it works with the rest of the boat.
Correct.
And then you choose the correct materials based on the job it's supposed to do, which is the example you were setting the other day with that engine room door versus the spaceship door. and that they're both doors, but they do very different jobs, and so they were built very differently.
Yep.
And they, different fittings on them, different sort of weight of foams and fibreglass, and the construction was completely different. So there is no one material is better than other. It's looking at what material is fit for the purpose.
It was most suitable for the job that's being done, and that's not just the material as regards to, this could be done with Nomex, but there's also a cost factor in things as well. So there's a lot of factors. There's cost factors, weight factors, availability factors, manufacturability factors, because if you can't manufacture it, a material, then it's completely useless. No matter how good the material is, if you can't manufacture or work with it, it's as good as a piece of dog poo in the grass in the corner. So it's very much about the person working with its skills, whether it's you or someone else or a factory or whoever it is, whoever is manufacturing it needs to be able to understand how to work with it. That's an incredibly important piece of the puzzle, because if you don't know how to work with it, then 99% of the time you're going to have a failure because you've not processed the material properly. So one thing to point out here is, again, we're looking at materials. This is a 10mm rigid PVC foam core. But now this is the second stuff. You'll see that there's all these lines here. This is because this is all end of sheets or end of bung cuts that have been glued together to recycle and basically take what the manufacturer would normally throw in the bin, make essentially a seconds product. Now, I would not use this foam core in a structurally critical part on this boat. So straight away, this core is not suitable if I was to make a bulkhead in this boat or a structurally critical component in this boat. I've got this core at this foam core at a very good price, and its intended purpose is furniture, right? Where the structural requirements are very low and its requirement as a structural member of the boat is super low. I'm using it in a highly structurally loaded component in the boat. Like we said before, this ring frame that we're building is a very structurally loading and very important piece of the boat. But I can use my shitty cheap foam core because its requirements in that member are so low that this recycled foam core is more than capable of doing the job. Okay, so that's having an understanding of your materials and understanding what the element you're designing and building requires, and actually putting materials that are fit for that purpose. I could put in here a piece of plywood. I could put in here this shitty piece of foam. I could actually put in there some really expensive Nomex as well, but I don't need to put some in. The requirements are that I need to keep the weight down. It doesn't have to be super structural, load bearing in the foam in its normal case, and the price of this is cheaper than plywood, so, and it's way lighter than plywood, so I'm on the win by using this instead of other materials. So you've got to take all of these factors into account, what materials are right for the job.
Well, I think this is the same stuff, isn't it?
Yeah, exactly. This is what that core is intended for. Furniture, super lightweight, skins, carries no load. The load, the massive load that is on this is the clothes from the outside, inside wanting to push out.
Yeah, so not a lot of
the loading on this is very low. boomerang.
Foam construction. It's taken a couple of days to put it together, huh? So you had to template it out of cardboard so that it fitted the side of the hull, and then glue it together, making sure it stayed straight. It's been a bit of a challenge. If you can see all those little blocks of foam there, little 10mm foam. This is what he used to get his spacings correct. And
Velvet on the table, didn't you?
okay, so this is going down into the hopefully cooler, because it's the middle of the heat wave here in Spain.
Et voilà.
Et voila.
It is French, but there you have it.
Okay, so that's going to be glued in there this afternoon.
Yeah. Well, I've got to remove this old bit, so it's not quite where it sits, but pretty close to where it sits.
And you were talking about unidirectional along this surface, correct?
Yes.
Not these side ones.
No.
So, and are you putting unidirectional on the actual hull as well?
Yes.
Okay, so we're going to have that unidirectional fibre running in parallel
Correct.
down there.
Very important. Yeah. For those that want to know, when I put this together, I currently have a 200 gram skin on the inside. This 200 gram skin is there purely to provide just a little bit of rigidity while I build this thing, and also to make it a vacuum tight structure. So it's super important that this is airtight, because when I vacuum bag, and in particular I'm going to infuse the laminate on here, I do not want to have a air leak to this cavity here. If I have an air leak into this cavity, this will implode. So
That's a good point. Yep.
completely crush. And
So is that skin on all three of those internal pieces?
Correct. Yes. It's
Okay.
on the sides and on the flange face.
And when you're infusing it, are you going to infuse it in situ, or are you going to
Yes.
do it a separate piece? Oh, so it's all going to be infused.
It's going to be infused on the job on the boat. So
That'll be
the
cool.
unis to run into the floor.
Yeah.
And the unis will also run into the deck.
Okay.
And I'll do all of the taping, so the 600 gram double bias will come around the box, down the flange and into the boat, and it'll all be done in one hit.
Oh, wow, Shayne. Okay.
What do you reckon, Mum? Do you reckon Paikea is going to be more scary now that it's lighter and stiffer? Or do you reckon it's going to be more fun? More nicer, more comfy?
Well, what we're hoping is that we can, instead of sailing along and then when some bad weather comes we have to reef, we will already be pretty quick with a third reef in or whatever, and we can just do ocean crossings in a pretty safe sort of sail configuration, and not be sort of, you know, having that 4 o'clock in the morning, oh my god, school's coming through, we have to reef, blah blah blah. We'll already be pretty quick in a conservative sail plan to start with.
Mm-hmm.
So that's sort of, you know,
While maintaining the speed. But
yeah. We know we could probably, if we can do 10 knots boat speed and only have third reef in and a little jib, that'd be amazing, because then we'll just sort of just cloud
of
through
that.
anything. Yeah. Okay, there it is. All glass spray tacked onto place. And next part will be a bit tricky because that's peel ply. Alright, so we fixed the leaky bit around the foam. That was what was stopping us getting a proper vacuum. And now, oh, what are we going to write on it?
I am Batman.
Why do you want to be Batman? I am Batman. Oh! Alright, Batman. Tell me, how many kilos did you say? 2.5?
2.5 kilos of
Yeah.
Resina.
Are we doing vinyl ester? What are you using?
We are using
Oh, look! It's Easy Composites polyester infusion resin.
Yep. It's pretty good. It says what it does on the box. And it doesn't suffer from boil out. So it's pretty cool.
Oh, that's cool because like that was what we were suffering with a few months ago, hey, with that other stuff. But it wasn't an infusion polyester, was it?
No, it was just standard hand laminating resin.
We have noticed too that now that we're lightening Paikea, it bounces around in the marina a lot more than before. So things like using digital scales and stuff get a bit tricky.
A lot more challenging.
Yeah, there's a bit of guesstimate going on. Might have to make another order with Easy Composites, Shayne.
Oh well. Watching the scales bounce around.
Now, is that 20 grams, Shayne?
I'm aiming for about 15, 16 grams, 1.5, just over 1.5%. So I'm going to stick this in here. I opened it a little bit to get that shot of air that's in there. Goes up. The resin hits the kink, the air goes past, and that gives it a couple of moments to let that slug of air in the line go through before I open the hose and shoot the part.
You almost made it down to the bottom. It's going through here. Oof. 2.5 kilos of resin, Oliver. Fair amount, eh?
Just chomping some resin pretty fast. Just imploded.
Damn. Do we want to turn off the vacuum?
Yep. Vacuum pump, please.
Did you turn off?
Yep.
Bit of leak in there.
Oh, that works, Shayne.
There's a week's worth of work just gone down the toilet.
Wow, so what happened?
We got a leak in behind the hollow section. Important that this is airtight. If I have an air leak into this cavity, this will implode.
So, air escaped from there, which made a vacuum inside the thing.
Yeah.
So, a vacuum inside plus outside.
The outside's not the problem, it's the vacuum inside that chamber.
So have you got to get it all off now before it dries, or just let it cure?
And then cut it off, grind it all up, clean it all up.
Oh my god. A lot of resin sitting there too.
Yeah.
I got that on video.
Awesome. What happens when it goes wrong?
Does it got a burner in it?
No, it's not.
Alright, I know what to put on Dad's t-shirt next time.
Don't let Batman touch it.
I hate boats.
The vacuum ended up inside the hollow section.
So how do you stop that from happening again?
I potentially put a hand laminate glass over the foam and the whole lot. See what happens.
So how you reckon it got in there?
I think that shitty foam that we use is quite porous with a so I laminated all the inside of it,
Yeah.
thinking that it wouldn't go through the edges and stuff. But what I learned from this little piece on the side here, that it's potentially got a lot more slices and cuts, and the glues aren't that great. So it's going. It's hot.
Oh, now we're going to make sure all that resin's not going to set fires or anything.
It would have been a well, it was a pretty quick infusion. I only had to hold out for like 20 minutes.
Yeah.
That's
Well, but some bits are still okay as well. Oh. Yeah, but those bits up the top didn't implode. Ugh.
yeah.
Compare the strip of tape. I hate boats.